Finally, how the Happy Vi were once again in the Encoding US videos begins this story with an apple that fell from a tree in front of the renowned physicist Sir Isaac Newton. This story shocked French astronomy 175 years ago today when a new planet was discovered without the use of any telescope or telescope. This statement served as the foundation for his creation of the universal gravitational law, which states that any two objects in space will be drawn to one another by their greater masses, which will also cause them to have greater gravitational pulls on lesser masses. Gravity is the term for this attraction. The entire solar system and the cosmos are subject to the force of gravity, not just our planet. Our solar system is the biggest and most basic example of it. Because none of the planets orbiting the Sun are larger than the Sun, they are all drawn to it and follow a unique orbit. Our Moon follows the same gravitational law as the Earth as it circles around it. The Moon is drawn towards the Earth because it is larger than the Moon by several times. The Moon, on the other hand, is small without denying its gravity. Although the Moon's gravity is insufficient to dislodge the Earth from its orbit, it does draw ocean water towards itself, creating waves in the water. We already know the outcome if for a split second it appears that the Moon is just stopping its orbit around our planet. The Moon will indeed strike our continent in a few minutes. As it orbits, a force is generated by its rounding, which pushes it outwards despite the Earth's gravity pulling it inward. The term centrifugal force refers to this force. Because the Earth's gravity and the Moon's centrifugal force are equal, the Moon rotates in its constant orbit. Every planet orbits the Sun in the same manner. It has been established through several experiments that the gravitational law of Newton underpins every system in our cosmos. This is taking place. Once thought to be the final planet in our solar system in 1840, Uranus was found a short while ago in 1781 with the aid of a telescope. This planet is 4 times larger than Earth. However, there was an odd anomaly in the shadow of this planet's orbit that prevented Newton's gravitational law from being applied to its full extent. Astronomers from all around the world studied Uranus night and day for 60 years, but they were unable to understand how it could defy gravity and break out of its orbit. According to Leverrier, there must be a massive planet or mass nearby at the point where Uranus deviates from its orbit for this to be conceivable. The only issue was that no one could spot any planet nearby. Leverrier Manuel claims that on the evening of September 23, 1846, he was once more lost in concentration as he gazed up at the sky. He then picked up a paper and pen and began performing long-width mathematical calculations. He designated a pinpoint location close to Uranus after the computation's outcome. He declared that at this moment, there is unquestionably another planet close to Uranus. In addition to determining its location, Leverrier also determined the planet's mass and came to the conclusion that it is the same as Uranus. After disclosing all of these details, he asked the largest observatory at the time to examine this specific region of space using a strong telescope close to Uranus in order to refute this notion. Dr. Johann Gottfried Galle of the Berlin Observatory first observed only a dark sky in that area of the sky, but after narrowing his focus, he was able to see a blue sapphire floating exactly where Leverrier had been. The sapphire's size was equivalent to Uranus's, meaning that 4 planets could fit inside of it. Recognize that if a tennis ball is meant, then it was the same size as a basketball. Because Leverrier's calculations and forecasts were so precise, Neptune, the 8th planet in our solar system, was discovered. The first planet to be found using only a paper and pen instead of a telescope is Neptune. Although Galileo always thought of this planet as a star, he also depicted it as both a planet and a star in many of his drawings. For this reason, Leverrier received all the credit for discovering it rather than Galileo, but Galileo always wanted this planet's name to be linked to his own name, Leverrier. When NASA's Voyager 2 spacecraft first flew close to Neptune in 1989, it was 3,000 miles distant. Voyager 2 took several pictures of Neptune. The final and furthest planet in our solar system is this one. Recognize that Neptune is 30 astronomical units away from the Sun if the Sun's distance is 1 astronomical unit. It is minus 10 degrees Celsius here because of the distance from the Sun. This is a massive ice junction where storms are constantly occurring, according to NASA. Hurricanes with a maximum speed of 2,000 kilometers per hour. Recall that the fastest storm ever recorded on Earth had a speed of 407 kilometers per hour. Here, a day is equivalent to 16 hours on Earth, while a year is equivalent to 165. Leverrier, the person who discovered this planet using just mathematical formulas, is no longer with us, but his adventures will always be brought to memory by this model of Neptune on his Parisian grave. I'm hoping you'll enjoy and spread the word about this film. I appreciate all of your amazing feedback on the upcoming video.